We'll be starting our next program by Mikael. The title is Infrastructure as Code for SUNET Drive, Sweden's Open Cloud for Researchers. Please.
Thank you. Hello, my name is Mikael Nordin and I work for SUNET in Stockholm in Sweden. And I put my contact information here. So if you find anything that we do interesting or want to collaborate on something, please get in touch. We do a lot of collaboration with different partners. So I will talk to you today about SUNET Drive, so Sweden's open cloud for researchers. I will tell you a bit about what it is and how we manage to deliver a reliable service that is currently used by thousands of researchers at about 40 Swedish universities that collaborate on about 400 terabytes of research data. So I submitted this talk with the label Infrastructure as Code, and I will talk about how we create infrastructure such as virtual machines, Redis clusters, MariaDB, Galera clusters, Kubernetes clusters, and more using GitOps techniques. I will not cover in detail how we set up and provision our OpenStack clusters from bare metal, however. So it's a bit hard sometimes to draw the line between configuration management and infrastructure as code, but I hope you will find it interesting. So SUNET is the Swedish University Computer Network. So it was founded in the 1980s as a research project for Swedish computer scientists. And it paved the way for internet in Sweden. So SUNET brought the internet to Sweden in 1986, I think. So SUNET today provides well-developed and effective national and international data communication and related services to universities. We have about 9,300 kilometers of nationwide fiber and approximately 750,000 users and 110 connected organizations. And we are also currently involved in building a fiber connection to Japan and Korea over the North Pole. So trying to connect Europe and Asia without having to go through the US or Russia and China. So SUNET Drive is a service similar to OneDrive or Google Docs. It has a user interface similar to Google Drive or Microsoft 365. The software allows users to collaborate on and share data with each other in a secure manner from Windows, Linux, Macs, smartphones, anything really. And everything is running on our own infrastructure in our own data centers in Sweden, which is important for a lot of researchers that want to feel that they have sovereignty over their own data. So the system allows users to collect data, store it safely, work on it, for example, using Jupyter notebooks or Collabora Online Office Suite, and then publish their findings to various repositories, such as Zenodo, Harvard DataWorks, or the Swedish National Data Services. All of this can be done in collaboration with any researcher across the globe or with industry partners. So accounts are automatically provisioned via single sign-on from an identity federation that is called EduGain, that has about 6,000 identity providers all over the world. And something that's very important to us is collaboration, and we want to be interoperable not only within the 55 instances that we are running as part of SUNET Drive, but also with other similar initiatives. So there's similar platforms in Germany, for example, SIBO, or the Netherlands has something that they call the Research Drive, and CERN collaboration has the CERNbox service. So we collaborate with these friends of ours, and we are also part of the development effort of the OCM specification, the Open Cloud specification that allows different software to share and collaborate on data and even share applications across different federated instances. Yes. We have we are running our services across 3 data centers. We have 2 in Stockholm and 1 in Kalix in northern Sweden. And the aim is to survive loss of a single data center and not have a single point of failure. So we want our customers to feel safe, and we want to provide them with digital sovereignty. And we also don't want problems with one customer to leak over or affect any other customer. So, but we also want to ship features in a timely manner. Some people say that perfect is the enemy of good, while others say that better is the enemy of good enough. But we don't want enemies, so we say that good enough is perfect. And we try to ship something that works and then iterate on it and improve from there. We have, like I said, 54 instances of Nextcloud running, and we have built the service twice, so 1 for testing and 1 for production. And that is crucial for us to ensure that we can deliver a good enough service for our customers. Yes, so the first thing that the user interacts with is our web servers. So those are running Nextcloud and proxy SQL. So we have 3 web servers for each customer, so for each of the 54 instances. And they run in Docker containers as systemd services. Nextcloud cannot connect directly to our MariaDB Galera clusters. So that's why we're using proxy SQL between Nextcloud and the databases. Then we have a cache layer. So initially we used Redis as the cache layer, but when Redis announced that it was going source available only instead of open source, we switched to the Redict fork that is community maintained. And we are also now a part of that project. And I, for instance, do packaging of Redict for the project. So we have a 9-node Redict cluster running for each customer to ensure high availability and good performance. And then we have the database cluster layer. So we run a MariaDB Galera cluster for each customer with 3 nodes in each cluster. So it works well across all of the data centers through all of Sweden and ensures that we can have high availability on the database layer. As an extra insurance, we also have an asynchronous replica attached to the cluster where we can run queries and do backups without impacting the actual cluster workloads. And as you see, we run many different clusters, not just a single big one for everyone. And that's so we can ensure resilience. And this practice forces us to be strict with our GitOps practices. So we cannot afford to tinker around with individual servers. We need to be good at managing clusters. So we also have for the customers set up Kubernetes clusters. So far we are not running Nextcloud itself in Kubernetes, but we have a lot of other auxiliary services running. So a discovery service for logins, we have Jupyter Hub, we have the software that connects to the different research data repositories. And we are actually deploying it as a snap package on Debian. And that's because we can manage it with our Puppet setup that we are running. I will tell you a bit more about that later. So we also have a management server or a script server for each customers. So we have a lot of automation running. So one of the key points that we provide our customers with is the ability to some extent customize it for their needs. So we can, some customers want us to provide each user with a specific S3 bucket for the user. Some wants us to have project buckets, or different types of customizations that we can do. So we can achieve that by writing automation that makes it easy for us to manage this. And we also do backups from these script servers. So we do full backups once per month and then incremental backups every day, so that we can push them to one of the different data centers. So we're not having all of the data in one place. So we can try to be safe from ransomware or data loss in general. So the hardware that we are running on is provisioned using Bifrost and Ironic and Terraform or OpenTofu, and managed using Ansible. So a major reason for us to do infrastructure as code and configuration management is that we can be cryptographically sure about what code is running at a given time. So we sign all of our Git commits using GPG keys, and our Puppet setup is deploying only commits that has been signed by keys that it's allowed to trust. So the chain of trust starts with physical access to hardware in the data centers by trusted technicians, but from there we take it to automated tools such as these that I have mentioned, and not just for security but also for convenience and making it possible to deploy the same software every time without any differences. Yes, so we separate code, images, and configuration in different Git repositories. So we write a lot of code ourselves, so mostly tooling, and like I mentioned, specific automations for different customers. But then we package these code in Docker containers, and then we have Puppet manage this configuration for us, deploying the images and all of this. So images are built on push by Jenkins, and they are only provisioned by Puppet if the signatures on the commits match what we allow. And yeah, so configuration is templated with Puppet using parameters from Factor and Hira. And secrets are managed by Hira eYAML, also saved in Git, similar to sealed secrets for Kubernetes. And then we provision secrets to Kubernetes from this Hira eYAML using Puppet as well. So the way we run Puppet without a master is something that we call Cosmos. So it's built on the Linux utility run parts. So, normally Puppet has a Puppet master, and each managed server is running an agent that receives instructions from a central node, but we don't want to do that. For security reasons, we don't want any single server to be able to take over all of our fleet of servers. So instead, we run without a master using the Git manifests and GPG signatures. So we want to be sure that only code that we want to be deployed is deployed. Yes. We deploy our Kubernetes clusters also with Puppet and Cosmos, and that allows us to continue the chain of trust that we have from the setup of the initial hardware. And then we can hand over to ArgoCD that also has the capability to verify GPG signatures in Git. So we can go from infrastructure as code to configuration management, and then over to modern CI/CD pipelines using a single chain of trust, starting with the technician that puts the server in the racks and connects the cables, over to the tooling I just described, giving our users a trusted storage and computing environment. Yes. So SUNET Drive is an academic toolbox for researchers and scholars, and they need to trust the computing environment that they are in. So we do our best to follow best practices and employ sound GitOps workflows to enable us to run a large-scale operation with minimal effort and high security. And yes, if somebody has a question, yeah.
You said that you sign the GPG commits with, your Git commits with GPG, and that's about the chain of trust and making sure you're running the right things. Do you guys ever go back and audit to make sure that you are actually doing that?
Yes. So we have a lot of different services that we run, and a lot of them are related to identity management. And we have a lot of different audits, external audits that we do. So it's crucial for us to be able to prove cryptographically what code was running at a given time. So we do both more automated compliance, but also a lot of manual audits from external partners.
And then, do you mind to follow up? When it comes to the configuration that you push from a Git perspective, does that mean that you wipe away the old infrastructure before, or do you have a process for managing the transition from one version to another?
Yeah, so it depends. So normal, what I would say, like pre-approved changes and things like that will go out and get to the running servers and be deployed by updating configuration files and restarting Docker containers. But bigger OS upgrades and things like that, then we wipe everything and install from scratch. So we have recently been moving our services between data centers. So that meant just destroying the old servers and setting up new ones. So I think we had 300 or 400 servers moved in a couple of weeks or something like that.
Thank you.
No? Okay, thank you.
Thank you very much.